Okay, so members, today we are going to see how do we use maclaurins theorem to find expansions of given functions. But please don't forget to subscribe to the channel. Now, maclaurin was of course a human being. He said that if you have a function f of x, you can expand it using his theorem. He said this f of x is the same as you evaluate that function at 0, then x, you get the derivative of that function, you evaluate it at 0 over 1 factorial, then plus the second derivative of that function, you evaluate it at 0 over x squared over 2 factorial, plus and so on. So this one is an ending series. It means that you can just that. It's the question to limit you where you have to stop. So there are many terms. So in this question now they are saying expand the following up to the term with x cubed using maclaurin's theorem. Of course, I'm going to handle this, you handle this every time. What you do first, you say let our function be now natural of the function you want to simplify, which is 1 plus 3x with this. Then after you start, you need to evaluate it at 0, you need this derivative, you need this second derivative, you need its third derivative. Why? Because the product after the term with x cubed. After the term with x cubed, we are ending at this term. If they say after the term with x squared, we have ended here. If they say the first 3 terms, you count 1, 2, 3. If they say the first 4 terms, 1, 2, 3, 4. So in simple terms, if they say x cubed, they want you to get the first 4 terms. Okay. So I need this derivative also. So mean that this derivative here, as I differentiate it, f prime of x. We know how we differentiate the natural. We differentiate this. When we differentiate this, we get 3 over the function, the original function, 3x. That's how we differentiate natural. We differentiate the whole of this. When we differentiate this, we get 0. When we differentiate this, we get 3. So this is the derivative over the original function. Now allow me to take this up. It will be now 3 into 1 plus 3x, the whole power negative 1. It's easier to differentiate it like that because this is a constant. Now we need the second derivative, meaning that now my f prime of x. Now the second derivative I'm going to make sure is we lower the power, we have negative 3. We maintain the bracket, reduce the power by 1, then differentiate the bracket, when I differentiate this, I get 3. This one I'm using the chain rule to differentiate this. So that if I simplify this, it will give me now negative 9, then 1 plus 3x power negative 2. Now I need the third derivative. Its third derivative will be now f down prime of x will be, when I lower this power here, it will be this times this, which will give me 18 because negative and negative. We say you differentiate, you lower this power, you get this power times this, which will give you 18. Then you maintain the bracket, reduce the bracket by 1, and reduce here by 1, I'll be having negative 3. Then differentiate the bracket, we get a 3. Simplify this, now this will be, this times this, I think that will be 54. 54 into 1 plus 3x power negative 3. So that's now, members, what we have. We have all the derivatives now. Now we want to evaluate them at 0. So this allows me to divide it here a little bit. Now I want f of 0. F of 0 will be, now f of 0 means where there is x, we put a 0. So in this function, I'll be having natural log of now 1 plus 3 into 0. So it will be natural log of 1, which will be a 0. When I come to this, still the same idea. Where there is x, in this derivative, put 0. I'll be having now 3 into power negative 1. Then, where there is this, I'll be having, is that this will be 0 plus 1. 1 power negative 1 is 1. Then you'll be surviving with 103. Then you come, you evaluate also this at 0. You'll be having now negative 9 into power negative 2, which will give you, this will be 1 power negative 2, which is 1 times this negative 9. When I come to this, it will be 18 into, where there is x, you put a 0 in this function here. So I'll be having now, this will be 54, sorry, this is 54. 54 into power negative 3, which will give you 54. From there now, members, you write the whole of this is for f of x. Now you put the things, so my f of x now will be f of 0 was 0 from here. Then x into f prime of 0 was a 3 over 1 factorial. 1 factorial is 1. Then plus x squared, then f prime of 0, which was negative 9, the whole over 2 factorial is 2. Then plus x cubed over 3 factorial is 6 into f triple prime of 0, which gave us a 54. Then plus other terms. You sure that there are other terms coming? You just ended here. So from there, now our f of x was natural log of 1 plus 3x equaling 2. Now this will be 0, this will be now 3x. Then this will give us negative 9 over 2, this negative 9 over 2x squared, then plus, here you see you can easily simplify. 6 goes in this number. You can easily simplify that 6 goes in this number, I think 9 times. So we have now plus 9x cubed. 9x cubed plus other terms coming. So members, that's how we use maclaurins theorem. Don't forget to subscribe to the channel. I wish you the best. Now, you can handle this, but when we are differentiating this, don't forget that when we differentiate this, we are having a negative 5. Here we have constants because when we differentiate this, we get a positive. But here, when we are differentiating, I'm going to get a negative. And now, when you put natural log of 2 minus, when you put here 0, like we had this function here, we're going to be made natural log of 2. Natural log of 2, you will put it here as that f of the natural log of 2. Here it was 0 because natural log of 1 is 0. I wish you the best.